telling you about a really interesting European project that we are conducting where SMILA is the strong technological backbone that we're exploiting, and where Intensity is a really valuable partner. So just a few words about the project. It is an AP project, so it is about integrated technologies. It lasts 36 months. We are more or less in the 6th month of the project, so we're just at the beginning. What I'm presenting you is the results of an initial design and implementation activities that, well, just started. So we are going to make much better than we are doing so far. I am from Politecnico di Milano, the biggest technological university in Italy. There is, of course, Intensity. We have Fraunhofer IDMT as a partner. We have, of course, Intensity, I said that already, CERT L3S at the Hannover University. Thank you. So, a good variety of partners with a good variety of skills. What we do, we want to develop an open search platform. What does it mean? We like to pursue 4 main goals. The first one is about the real core difference of CUbRIK, that is about involving humans in the loop. Why is this important? Because there are a huge amount of tasks for which machines are really good. I mean, we really reached the state of the art where we can rely almost completely on them. But there are a huge amount of tasks for which machines are really bad. I will tell you a few examples of those. And it has been widely recognized right now that by injecting human computation power, let's say, into those technological architecture again, it is possible to achieve better results. We want to address a specific field, that is the field of multimedia search. We want to deal with multimedia objects, video, audio, images. We want to do it in an open way, which means that we would like to develop a platform on top of SMILA that is going to be available for third-party companies, universities, researchers, in order to work with and to improve on eventually. And we also would like to have a search business ecosystem on top of that. In my presentation, I want to stress those first 3 points, so I would like to go more technical if I can, not too much, but a little bit more technical. As we know, I mean, every search process, particularly multimedia, basically composes of 3 sub-processes. An indexing process that is about getting raw contents and extract meaning out of them. This is a main goal of creating structure out of a structured data. Multimedia is a really good example of a structured data because they're just zeros and one in the end. A query process that is about expressing a user information need in a way that is near the language and the idea of the user, and transform it into something that if it is efficiently executed by the machine underneath the system. And also feedback processing that is trying to put back in the loop the feedback, the sensations, the outcomes of the search processes, so to reinforce and to improve the performance of the underlying system. We're talking about processes here, so we're talking about tasks executed by some actor in those processes. We need a way to orchestrate those processes. We need a way to do it in an open manner, in an efficient manner. So very much of the terminology here might be familiar to you if you have some, as I'm sure you do, knowledge of SMILA, because we're talking about components, so software, algorithms that have to work in an organized fashion in order to achieve a given goal. And this organization is what we call a pipeline, so an orchestration of a sequence of activities. Each application defines, of course, ad hoc pipelines because, I mean, the business goal or the goal, generally speaking, are different for each scenario. Although we believe that there is a good amount of usability and modularization that can be brought up and exposed as a contribution, especially eventually in the multimedia field. So this is a really high-level architecture of what we are doing. So we envision a process repository that is a place, an open place where people can inject components and pipelines in order to be reused, recomposed in new applications. We do have, of course, a strong service platform down here. First of all, a process execution engine that is the component that allows those processes to be executed in a reliable way. We also want, and this is one of the part that is specific of CUbRIK, we also would like to exploit humans in those processes. We would like humans to be part on the indexing pipeline, content analysis pipeline. We want humans to have active part in the query pipeline, not only from the point of view of who's having an information need, but also from the point of view who can contribute to such information need. We also wanted to leverage extensively the notions of space and time. So the fact that the information is often georeferenced and also often provide time-wise information, something that allows to recognize better the objects, the events, everything that is happening and, or that occur in the objects that we are analyzing. SMILA is the backbone of CUbRIK. When we first thought about writing this proposal before the EU accepted it, it became really natural for us to select, to pinpoint SMILA as a reference platform, because I mean it had everything that we wanted. It was open, it was flexible. So we're really thankful to Authenticity that they agreed to take part of the project. And now, building on SMILA, we are extending it. We are providing additional components, additional features that are meant to address the specific case of multimedia search with humans involved. So we would like to have multimodality. So we would like to have workflows that interleave components that are machine-driven, so algorithms, and components that are driven by humans. So humans that execute the work of machines, if you want. We would like to have time and space awareness. So we want to leverage those features extensively. We want to support human computation. I'm sure you're familiar with that. There is a huge trend going on lately, mainly driven by initiatives such as Mechanical Turk, for instance, where, again, people understood that there is a need for an artificial intelligence. There are tasks for which machines are not able to perform really well. Image classification, for instance. Speech-to-text transcription in scenarios where the domain is not known a priori, or where the quality of the content is a little bit low. Sometimes semantic segmentation, interpreting text, making summary out of text. There are good techniques that works really well, other that works a little bit less well. So we code machines to do those tasks in order to try and have them reproduce our mental, the work of our brain. The problem is that we have been trained, we evolved in millions of years in order to be able to do such tasks, and we are extremely efficient in doing that. And even though we try to scale machines and algorithms to new boundaries, then, well, we're simply not able to solve those problems efficiently. So that's why we want humans to be back in the loop. We want them to allow some of those tasks that have low precision, low confidence, where the algorithm cannot reach, then machine can intervene. And this is what human computation is about. We also would like to exploit the social environment. So exploiting, leveraging social networks, social communities, information about the humans that should perform the tasks in order to be able to address the best task to the best executor, the best performer. I will give you an example here for the log detection demo. So this is basically what I just introduced. So there is uncertainty, a given level of uncertainty beneath every and each algorithm. Some are better than others. Face recognition identification is a problem which is more or less solved. It has been proven to scale to billions of images. Others are not, well, performing that well. So again, using human to solve those kind of tasks. we want to integrate this. We want to have these capabilities of human computation be part of algorithms in order to improve them, be parts of analysis and query platform in order to improve the performance of such platforms. And this logo detection demo, this logo detection application is just is one example. So the problem is about identifying objects into images, specifically into videos. It is a classic computer vision problem, which is, well, it's proven to work well in given control scenario, but sometimes it just doesn't work well because it requires, well, given background knowledge about what we are looking for. I mean, it's basically pattern matching. Logo detection is an example of such a problem, and what we like to achieve basically is to have a solution for advertiser, companies, you name it, in order to know how many times where a given logo appears in a collection of videos. So I don't know, I am the responsible for the marketing of Coca-Cola. I would like to see how much my brand has been exposed in a given television channel, I would say, because I would like to check my contract if it's been complied with or whatever. So there are plethora of applications, rating effectiveness, subliminal advertising. I mean, the example is rather simple, but it has a lot of good applications. What we would like to do again is to try and integrate human automatic computation. How can we do that? We can see two main problems, actually. Two main problems in logo detection. The first one is about having good examples of logos so that we can find them. The second one is, I don't know, Coca-Cola has several ways of having their brand done, depending on the nation, depending on the period of time. The second problem is about the confidence on finding the specific brand and logo into videos. So those are the two parts that we would like to exploit with human computation. So how we can have humans helping? Well, first of all, by trying to help us having good set of logos to look against. We do that first by looking up to Google and trying to download as many logos as possible for a given brand. And then we have humans trying to polish, to filter out all the logos which are not deemed as good by the human performers. The other contribution is about validating the matching results. So every time that the machines find the logo in a video, if the confidence of the algorithm is low, then we ask human to verify it so that we are sure that the outcome is as much as precise as possible. This is a high-level view. This is actually an annotated BPMN of the pipeline. So really quick, the idea is that given the name of a logo, Crystal Geyser, this is the example, then I retrieve the images from Google. I have humans validate those images. Then I match those images again in a video collection. And then for those matches for which we have low confidence, then we ask human to validate the results. And the end is the report. So a summary, a brief summary of which videos contain the given set of logos. Methodologies for defining the problems to be solved. A way to abstract the performers. So how are we going to exploit their social feature, their skills, both as pure human or as performers. And then we need to execute those tasks, being sure that we assign the right people to the right tasks. And after evaluation, then we can aggregate the results and re-inject it back into the workflow as if it were produced by machines. So again, closing the loop. Those are the tasks that I'm talking about. So validate logo images and low confidence results. If you're interested, of course, afterward we're going to have a little demo about this system. So I won't indulge too much. Something that I would like instead to stress a little bit is about how do we want to involve people, because not everybody is good for performing tasks. Just the example of logos. There is a strong geo-cultural component in place, because for instance I may be able to recognize a Coca-Cola logo in English, but I might not be able to recognize it in French or in an Arabic language. So geography also culture, because some products, for instance, may be known to some countries, other not. So we needed to find a community of people, and we needed to have those people to be assigned to those tasks. We need a way to define how people can interact with the platform. So in this case, it was really simple. We just gave them two kinds of tasks. Identify the logos which were okay, or add a new example of logo in order to be processed. Assigning people, as I said. So what we ask people to do, which one are the most deemed to answer to these selection questions, which one instead were better deemed to answer to the other question. There was this not trivial expert finding process, which I mean, it has ramification in several scenarios, but in this case was about finding the right person that will be able to recognize and suggest new instances for a logo. We exploited Facebook, the Facebook graph, this time, but we have work in progress in order to expand to other social networks. And well, this is an example of what we achieved by embedding the application into Facebook and asking people connections of researcher or our friends, let's say, to answer those questions. And what we came out with, well, 40 people basically, 7 collection answers. What we came out with is a good example of the premise, the hypothesis that we are making. So each one is a different kind of logo, and this classical precision recall graph basically say how much the system were good in spotting logos in video according to the presence or not of a crowd, of a generic crowd answering, or the presence or not of experts answering. So we can basically see a pattern here that is expert, of course, outperforms any other options because they are the one that they know the most about the given domain. Crowd can be good or can be bad according to how we use it. So for instance, we have this example where crowd is really bad because we actually included the wrong people. So we were asking people in Italy to answer questions about logos that were just known in the United States, for instance. That was wrong. So the strong importance about assigning people again. Another problem it was about even though knowing the tag, so having a good geographical property correctness was about knowing really well the domain. So in this case, you might more or less understand that those belongs to the same company, but then those are two different brands. So you may deem something correct even though it's not, because you don't know too much about the domain. Well, this one I can skip. Integration is SMILA. I will skip really quickly to this one because I have 5 minutes.
No, 10 minutes left.
I have 10 minutes, so I can...
Start it 5 minutes later, but if you can do it in 5 minutes, it's okay. But you have 10 minutes.
Okay. The most of these I can explain to you if you want after, where we're going to have the demo session. This is going pretty technical. So I would just like to telling you how we integrated SMILA in all of this. Well, again, SMILA was the backbone. It was the technological framework on which we built our processes. Several processes for this application, because as I will show you, the task here, it is more involved than it might seem, because we do have an indexing part and a search part, but we have features which are pretty unique. That is longer asynchronous process. That is, when you involve the crowd, you cannot be sure how long will it take for the crowd to execute their task, which means that you have to stop at some point and then start again. You have typically in search system, you either define the collection of documents or the set of queries, right? Here instead we have both. We needed to have the ability to inject new contents as they come and also new kind of queries as they come. So it was like a conflicting goal. We needed to optimize both. And really high level, this is what we developed. So we have SMILA here, here, and here, again, hosting and executing the main workflows that we need. The search one and also the indexing one. And on top of that, we developed our custom web application for interaction with the user and well, also for search. this is the maximum that we'll get in this presentation. Eventually, afterwards, I can explain to you. So this is how, from a high-level view, the system is developed. Here we have the first job that, given the name of a brand, try to retrieve from Google the list of logos that may be good. This list of logos is then analyzed by the crowd, by a set of humans. Then through this component, this newly developed component, this conflict resolution manager, defines which logos are good and which are not. Once this has been defined, then we're going to index that logo. In this case, we apply an algorithm that identifies key points in an image and compare those key points with a given example. So indexing in this case is about segmenting the original video into semantically coherent segments and then pinpoint the right frame to go into and find for the logo, analyze if there are logos, and then store a compact yet efficient representation of those logos into an index for efficient retrieval. On the other hand, we have the collection of videos that needs to be analyzed. This video indexing process is more or less similar to this to the logo indexing one, meaning that we apply this segmentation on the temporal dimension of the video. So we define temporal segments. Here was about temporal spatial segment. And once we define those compact representations for the logos that we find out, then we match the frames with the logo. The ones that were okay goes directly into the index. Well, in this case, we use Solar. Otherwise, the ones that are not okay are again subjected to the evaluation of the crowd, which evaluates whether logos were okay or not. Finally, we have this last job that is the one that updates dynamically the index in order to add the comparison done by the humans that were deemed to be good. Again, I just go really quickly on those. I'm here if you want. Afterward, to explain to you, afterward we're going to have a little video for the demo, so there is a specific time slot for that. So again, I just keep. Just wanted to conclude by saying that this is, well, the first attempt that we did in order to introduce this human component within the problem of multimedia search. Within the project, we are actually going to have several showcases and demonstrations, again, all based on the SMILA framework and architecture. One of them will be about history of Europe, so analyzing connection of images and videos coming from old archives that have been digitalized and then from which we want to extract information that is not available as textual metadata. You see again, multimedia, unstructured data, go to the structured data, and also a business case scenario for small and medium enterprises in Europe. Specifically, we want to develop a garments search system, so to find purses, accessories, something like that, into image collection. We're going to evaluate this in real world, so having to deal with real user, and well, of course, we continue with our technical demonstration, and maybe next year I will be here to give another one to you. That's more or less it. I think I was able to keep myself into the 5 minutes. This is the website of the project, CUbRIK project. This is instead another website that is about the component that we're using for human computation. The site is under maintenance, but we're going to update it really soon. I think I'm done. Thank you for your patience also. Thank you.
Yeah, Alessandro, so much. Are there any questions, annotations so far from this side? Comments? Yeah?
Thank you very much for your presentation. My question is, are there any overlapping or connections from CUbRIK to the Quero multimedia search development in France?
Well, we know, meaning that we don't have a partners that actually also are in that initiative, as far as I know. I hope I'm not wrong. Although, of course, the scenario is really similar. I'm not aware, but again, it might be my own lack of knowledge of activities in the project about that.
Thank you.
So, yeah, any further questions?
Was it easy to find enough people of the crowd?
Well, sometimes it's underestimated the willingness of people to help. It is about finding the right incentives, the right motivations for them. So one, of course, is money, but it's not always the right one. Another one is social awareness, is raising above the peers in order to appear more, useful or competent about a given topic. So in our case, it was more about willingness to help, because we asked a set of people that directly or indirectly we knew in order to help us. It wasn't biased it was biased because, of course, the diversity of the population was a little bit limited, and then we came out of those problems. But it wasn't biased by coercion. I mean, we asked them politely, and they willingly helped us. There are a set of experiments that shows that given the right environment, people are more than helpful and willful to help. For instance, and then I really close, people spend a huge amount of time playing games on their mobile phones. Why don't allow them to do something useful besides playing? So there is this huge field of business and research about game with a purpose. So having people execute tasks while playing games. And in that case, well, it's really easy to find people that want to play games.
Okay, so then one final question. Will you show the demonstrator during the demo sessions?
Yeah, I have a video.
Okay.
I hope it's...
Yeah, okay. Thank you very much. So again,
Thank you.